Hello, welcome to this video on Curve of the Earth Measurement version 1. Here I am back on flat Earth again. This thing just won't go away. If you've seen some of my other videos on rockets in a vacuum, you'll know that I have this friend he's a flat Earth believer, and him and I have been having this dueling match for quite some time now about Earth's flat, NASA didn't go to the moon, and rockets don't work in a vacuum. And anyway, I did a test, my video on rockets in a vacuum, version 1, and we had everyone gathered around for the test, and everyone running videos, and had the movie cameras, mobile phones set up, and I turned around to set my high-speed camera up, and I accidentally hit the button and started the test before anyone was ready. But I happened to catch the look on my friend's face, and he was absolutely rattled. He was devastated. He was so gobsmacked that this thing actually worked in a vacuum, that because his whole belief was that rockets don't go to space because they can't work in a vacuum. So because of that, I made Rockets in a Vacuum version 2, and I made sure that I dotted all the I's and crossed all the T's on that experiment because it meant so much to him. And like a lot of other flat earthers, I believe that they think that rockets don't work in a vacuum, which is a keystone to why the Earth could be a globe and NASA don't go to space. So anyway, we started this dueling match, and he came back at me. This time he's regrouped like the phoenix and risen from the ashes, and he's adamant now that the Earth is dead flat. So him and I are into this experiment. Just to me, it's a bit of a sideline, and I enjoy doing it. But to him, it's quite serious. I'm looking at YouTube videos, and I'm thinking, how hard is this to measure? For goodness sake. Aristotle, the Greek scholar, did it 200 years BC. You know, here we are with laser beams and theodolites and high-tech cameras, and we still can't sort this thing out. So I got onto YouTube, and there has to be, there looked to be maybe 5,000 videos out there. This thing has gone berserk. The whole world is looking at this flat Earth, so maybe there's something in it. I'll have an open mind, and some of those videos are very good. Some of the science is very good. I'm starting to doubt myself. Maybe the Earth is flat. So I need to clear this up in my head. So what we've done, we've come up with version 1. No doubt there'll be some faults, some classic mistakes, but we need the repeatable experiment. That's the only way that civilized scholars can actually solve. That's how dueling matches. The weapon of choice is a repeatable experiment. So here we go, and we'll start off with the basic concepts of what are out there with this, how the flat Earth is. As far as I can tell, there's two major trains of thought with this flat Earth concept: the globe's concept and the flat plane concept. And there's variations of this where the moon travels around and the sun travel around it, as opposed to our global concept where we travel around the sun. So we're all familiar with our globe, and it spins on an axis. So I started looking at videos on YouTube, and I came up with probably an exaggeration. I said there's 5,000 videos on flat Earth and how to measure it, but maybe that's an exaggeration. There's probably about 1,000, and I started to eliminate some of the rubbish from the good stuff, and the ones that I started, the first thing I looked at was this concave convex system, where you can have Now, I still have our flat Earth, but it could be concave or convex. Oh, sorry, convex and concave. Any video that I seen didn't recognise that concept. I eliminated. So in other words, the ones that showed this and this, I accepted. So I started zeroing my count down to what was good and bad. Any idiot I've seen measuring anything with a spirit level, there's one of these things, you know, where you, for accuracy, eliminated them. Anyone who showed someone else's work, you know, they quote, this is typical YouTube, have a look at this video, this guy's done this. I got rid of them. They're just rubbish. No one takes the time to do an experiment themselves. That's just a waste of time. The laser guys, some of them were good, pretty good. Some of them knew what they're doing. Again, a bit of a bit hit and miss because, as far as I know, as far as I know, a laser over the distances. If you have a look at one of these laser pointers, the dot is fairly small over a short distance, but as you go over many kilometres, the thing ends up, you know, the size of the target you're actually aiming at, which could be something the size of this. So the accuracy falls. However, I believe there are some theodolites out there. If someone wants to send me one to experiment with, I'd love to try one that can go up to 1 kilometre or 2 kilometres in measurement to give you a pretty accurate, but I'm guessing these things are in the $100,000 bracket, so even just a higher one would be out of my budget. So in all, I got the number of videos on YouTube that have any credibility down to about 5. So of those, people showed a high level of intellect. Anything to do with flat Earth, these people are no dummies. They have to be treated with a lot of respect, and they've come up with some damn good science. So I can only I can't copy them, but I have a lot of respect for these people, and I have to do my own experiment. So let's start with where I started from. Most of the videos you'll see on YouTube are all done with over water. So why do we use water? Basically, for short distances, say you want to put up a carport and you want to put a beam across two uprights, you can use the spirit level, no problem. Anything up to 10 metres, one of these things is fantastic. If it's a really big building like an aircraft hangar or something, we use theodolite these days, which is a laser beam that goes straight across, and these things are dead accurate. For something on a distance of 1 kilometre, we have to go back to what the ancients used. So the ancients built things with what was called a water level, and these are great for anything from 1 metre to around the world, I guess, you know, hundreds of metres, thousands of metres. Very accurate, and they built the pyramids with something like this, which just you can stick it between 2 posts and you can find the level real quick. But the only problem is, for up to 10 metres you have a tube size around about that big. For 100 metres, 1,000 metres, and that's something out of everyone's cost range. So what we use is a lake. Now let's assume that the Earth is a ball, or it's flat but has a convex surface on it. So it can be this shape here. How am I going to measure if it's curved, round, if it's curved, convex or concave, or dead flat? How can we measure that? So we have to do it over a long distance. So in that case we have to use a water level, which is the poor man's theodolite. And that's what we use to, that's why you see most of these videos over lakes, or again, if someone wants to send me a theodolite that'll go 2 kilometres, then great. But as far as I know, the only way to do it is with water on the lake or a flat body. Alright, let's assume for a compromise, we'll assume that the Earth has a convex curvature and a flat bottom. Okay, we compromise between a flat Earth and the globe. The curvature of this convex arc is the same as the Earth we have at the moment, the globe. How the hell am I going to measure whether it's convex, concave or flat? So what I did was I came up with the standard maths that everyone's come up with. Is, let's use the imperial system for the moment. 8 inches for 1 mile. So that means that for every mile you go, the rise of the Earth goes up 8 inches. There's a curve. So most optics is limited to a 1 mile, or roughly a kilometre. Okay, there's the military have got stuff that goes 2 kilometres, maybe 3, but you and I can't afford it. So we work in this margin here, 1 mile. So that's roughly where I was. So I set up a telescope and a target, roughly within this dimension. And okay, to see over a kilometre or a mile, you need a very good telescope, a land-based telescope, very good optics. Now, most of us can't afford one of those, so what people are doing now, they're using these digiscope. It's called digiscoping, which is like a poor man's long-range telescope, which is basically one of these spotting scopes you buy from eBay or optical shops. They're around about the $200 mark, and they give you pretty good optics at about a kilometre, a bit longer. Now, they know any video you see out there with people using lenses that go 2, 3, 4 kilometres, be a bit wary of them, because the optics, unless they're military grade, you're not going to get very good resolution. This thing here I modified. A camera goes on the top here, which you'll see later on my videos, and I can up and down it real quick with the adjustable legs. Stick it in the water and it's ready to go. It gives me poor man's optics for about a kilometre. Right, so what we needed was a large body of water that was relatively free of waves and nice and calm, and to conduct our experiment. And I found the ideal spot, Lake Tuggeranong, Canberra, Australia. Basically, it's probably the most ideal spot to conduct any flat Earth experiment in the world, and it only gets better. It's a man-made lake, and it has a large 2-lane road going across a bridge and a smaller footbridge in the background. But there's a row of buoys that run along, and right under the bridge there is a 200mm buoy, that quite an orangey yellow buoy. It's illuminated quite well. And this section here is a beautiful sandy beach with a very low incline to it. It's gradually increases from probably a few millimetres up to a metre within a long distance, so you can paddle into it. So this distance from here to this buoy is 1.2 kilometres. So Yeah, so 1.2 kilometres is perfect distance for my optics, and I couldn't get a better lake to try out everything on. So the next lot of slides will be my setup in the lake and what I found. Here we have a Google aerial map view of the 1.2 kilometre stretch from the sandy beach to the marine buoy under the bridge. This caption shows the large road bridge in the foreground and behind it the smaller walk bridge. Circled in red is the marine buoy, that's the target, and to the right you'll see a pelican circled in yellow to give you an idea of the size of the buoy. This caption shows a long distance view to the bridge. I'm standing roughly 2 metres above the water line, just to give you an idea of the range we're looking at. This caption shows the buoy through the telescope 2 metres above the water level. Quite as clear as the lens from the camera, but still you can make out the buoy quite clearly. This caption shows the camera and telescope assembly. Notice that the centre of the telescope lens is at 110 millimetres above the centre of the water, which should clearly see the buoy according to the calculations. Here we have a view through the telescope with the telescope 110 millimetres off the water line. I cannot see the buoy. Notice that however I have the water level and the horizon dead mid-screen, which means the telescope is level. I was just about to give up and try and look for some other means to find the buoy, and a strange thing happened, which the next shot will show. Yes, I was just about to give up, and I was wishing I had some sort of remote control boat that I could sail across, and all of a sudden this pelican decides to swim across, and it gives me an idea of the view. Notice the beak is just the body is hidden, but we can still see the beak. Quite an interesting concept. Anyway, more on the pelican later. Here we have the telescope raised almost 3 times as much. I just had to remove the camera for it because my smaller camera's batteries went flat. But anyway, this just gives you an idea how high it was. With the telescope raised, I still couldn't see the marine buoy. However, with luck, my mate the pelican returned, and you might notice a strange effect around his beak, and we'll talk about that a bit later because I think this is the key to what's going on. This is a caption of the buoy under the bridge. Gives you an idea of the size, and I had the waves came up a bit later on, so I had to give this away, but the waves weren't this bad when I was taking the photos. I showed the photos to my friend to help me explain why I couldn't see the marine buoy, remembering that we're 400 metres short of the 1 mile limit. The ball should be easy to see. He suggested take some photos in the early morning when the temperature is a bit more closer to the lake temperature. However, the problem was that the air is now murkier. As you can see from this, there's more moisture in the air. Same as before, telescope just off the water. Telescope raised. Notice the angle of the shadows and the heavy reflection of the trees in the background. Caption of telescope at water level. I showed this photo to my friend. Circle in red is what I believe is the buoy floating above the water. My friend said no, it's not. It could be the buoy, but more likely a reflection of what is circled in green, possibly a plastic milk bottle caught in the lip of the spillway on the weir behind. He said go back and check. Zero 900 the next day. What appears to be the milk bottle still jammed in the weir. Notice I no longer can see the reflection of what appears to be a buoy in the water. Strange that the milk bottle should be still there. On my journey to recover the milk bottle stuck in the weir, just rechecking the buoy. Yes, definitely white on the top and orangey colour on the bottom and fairly well out of the water. Passing under the bridge. Footbridge, spillway and weir. Zoomed in view of what appears to be white milk bottle or some object. I need to walk out on that tip of that ledge to get a photo of the so-called milk bottle. Doesn't appear to be a milk bottle, but some sort of metal grate sitting on top of the weir. Here is a view from a different angle. Unbelievable. This is what the sunlight was reflecting off the corner of this large piece of metal. View from top of the footbridge back to where the telescope was set up, circled in red. View of weir from the footbridge. I think we'll go back to the whiteboard and sum up what we've got. Okay, we're going to sum up now. From the results we had, basically the pelican was probably one of the best examples we had of what can happen. If we had a dead flat Earth, in theory, we should be able to see this ball. In our situation, because we're 400 metres short of the mile, at 1200, we should have clearly seen the ball with the telescope at water level, no doubt about it. However, we couldn't see it. Now, my friend he came up with a theory, that basically what's happening is that we've got this mirage effect from the inversion layer that's around this level of the water here, whether it's, we don't know, that we can't determine how high this mirage level is, this inversion layer is, but somewhere between about a metre off the top of the water. And what happened is, if you have a closer look at the pelican, the beak on the pelican, you'll see a bit of a reflection, which indicates that the Earth could be dead flat, it could be convex, or it could be concave. We do not know. All we know is that some mirage effect made the water level rise up. And we assume that it rises up like this. However, the flatness of the horizon may be the same, maybe convex, maybe concave, or dead flat. We do not know, and we've got no way of measuring it because of this inversion layer that sits roughly 1 metre above the water level. And remembering that you had a look at the pelican's body was roughly this size here, just a little bit above, and its neck came up just a bit above this horizon of the water. Also, the next shots on the next day indicated that we had the lake temperature was around about the same temperature as the air above, and we had some weird reflection looks, which brought us to go and investigate the reflection on that we thought was a milk bottle. However, we've come up to the results that we can't explain the results. We can only put it down to a mirage effect, virtually calling it a draw, and we have to go back to version 2. He's thrown some extra mathematics in. I'll just add it on after, just this little bit here to show you what could happen if this the drop was actually according to this 200 millimeters. Strange effect, but I think we just have to regroup. So I'll just show you what I've come up with, probably for version 2. My friend's quite spiritual, and I had to give him some respect for what he believes, but what he's come up with has scared the hell out of me, and I think he's quite right. He's come up with this theory that the Creator has never meant us to see the horizon as it surely is. There's actually, if you can see from this mirage effect, if we look into the horizon, we see a virtual horizon, and we see the optical horizon, and we see the true horizon. So there's virtually three horizons we see. So when you go to look at something, sure, you can put a ball, roughly what your eye could see, and if you have a look at those lake shots, we're looking at something the size of a pinhead in those long views. That's what your eye, roughly the camera is set up to visualise your eye. So we're seeing a dot that big, and we're trying to work out if we can see it with our naked eye or in this murkiness of the mirage, this fairy dust air. And my friend reckons that there's this zone, whenever we look at the horizon to try and find out if the Earth is flat, round or whatever, we will never be able to see it, because whatever we look at is in this zone here. Sure, we can make it large, we can stand up on top of a mountain and look further, but then we have to make the object smaller, and it always will be in this zone here. There's nothing we can do. You might see photos or images of cities across a lake, and they say, well, there's a mountain, there's the skyline of a huge city. But what you've got to remember is these people are now standing up on something taller, so they should be able to see further, but they have to make the object smaller to put it in perspective. So again, it zooms back down into this zone here of fairy dust air. So a clue came to me, something, again, this spiritual thing. I must admit that episode with that pelican freaked me right out. Something brought me to this, remember this white milk bottle we've seen on the top of the weir? And it gave us a clue that maybe there's a way around this. Remember that we have a large body of water from where I was at the sandy beach to this spillway, which is a roughly 2 metre high cement wall, and there's a spillway of water just ripples over that. Now what we could do is we could actually raise the level of the telescope 2 metres above this murkiness. So we're no longer relying on looking at the horizon. We've actually created a false horizon up here. But our object is still only small. So we actually we're circumnavigating this mirage effect. So now I'm 2 metres above, and I can place my object on this water level up here now. So effectively I've stretched this out 5 kilometres over a 1.6 kilometre distance. So that's what we're thinking. That's what we're going to go to. And also, miraculously, remember that grate, that large metal grate sitting up here. Believe it or not, I rechecked that, and it's dead parallel with the water. So we have another reference. It's almost like this is freaky things happened here. So that's our sort of stage for version 2. We're going to sort of try and get some better optics and some better setup and some better temperature measurements for water, and come back and re-look at this. So thanks again for watching this video.